Hello everyone. Today I'll introduce a solution to enhance the visualization of patient histories using FHIR bundles. Let's start with background for this tool. FHIR bundles are widely used in healthcare to exchange complex patient data. Current tools focus on displaying the information in tables or networks, which are not optimal for understanding time-based patterns. Research shows that timeline visualization enable providers to better recognize trends and make informed decisions, which underscore the need for time-based tool. Our solution is a web application that transforms FHIR bundle into easy-to-understand timeline. User can upload a JSON file, visualize time-based events like diagnosis and treatments. Also, he can receive an LLM-generated summary of the data. This enhances pattern recognition and supports clinical decisions. Our tool benefits both patients and providers. Patients get simple way to understand their medical histories and have better conversations with their doctors. Providers can quickly review the key details and make better decisions. Because our system is built on the FHIR standards, it can integrate easily with current systems. Overall, it helps reduce errors, improve care, and save time. Our project was a collaborative effort with each team member bringing unique skills and expertise. While it was challenging to separate tasks since everyone contributed to all aspects of the project, I will highlight some key contributions and top achievements from each team member. Joshua took the role of project manager, software architect, and full stack engineer. He developed data extraction tools, created the core code for using Google Gemini API. Also, he improved the UI with accessible designs. He also documented the deployment process. I worked as full stack engineer and technical writer. I built React components for patient data, automated data processing workflow, and integrated components together. Also, I worked on the final submission paper. Grace played the roles of data engineer, full stack engineer, and documentation lead. She managed the data, created ETL scripts to transform the data to the desired format. Also, she updated the architecture diagrams and improved the Gantt chart while contributing to the final paper. Songlin served as a full stack engineer and UI UX specialist. He built the app structure, improved the UI with layouts and markdown, and he added error handling to the system. Also, he contributed to the final paper.
This is Josh Baker, and I'll be covering the discussion and research retrospective section. As we were brainstorming ideas for our project, we suspected that it would be useful to be able to visualize the contents of a FHIR bundle as a timeline. But we needed to perform some research to validate that 1. This capability did not already exist, and 2. This capability would actually be useful to healthcare providers. So we performed some Google searches for FHIR bundle timeline visualization. We actually did find several public-facing tools online for working with FHIR bundles. However, while these tools allow for some basic introspection and navigation of FHIR bundles, visualization capability is limited. For example, the ClinFHIR tool from InterSystems allows a user to upload a FHIR bundle and navigate the bundle via a basic collapsible tree interface. But unfortunately, we can't visualize the contents of the bundle in a timeline. Similarly, the MaxMD's FHIR Bundle viewer extracts resources, groups them, and shows them in a tabular view. While this is certainly better than looking at the raw FHIR bundle, this table isn't exactly a data visualization that facilitates a provider in making a diagnosis. So based on our survey of existing tools, it does seem like there is a gap. But are timeline visualizations even useful? We turned to Google Scholar and found a couple of academic articles that suggested timelines are useful. For example, Ledesma et al. Found that their health timeline visualization assisted participants in generating higher value insights. A second paper by Belden et al. Performed a pilot evaluation of a timeline design and showed that they improved physician performance in 5 common medication-related tasks compared to tabular presentation of the same information. With our use case validated, we next performed a systematic review of the Level 4 FHIR resources to identify those that both had a timestamp and will be useful in a timeline visualization. Based on this review, we ultimately selected encounter, condition, procedure, observation, claim, and medical administration resources for inclusion in our timeline.
Hello, this is Songlin. I'll be covering achievements and challenges. First, let's go to the achievements. In our project, we have several integration points because we have used several techniques to build our app. We use PyScript and JavaScript when we process the data, and we use the Gemini server API for the generative tests, especially for the LLM summary. We also use Git page as a deployment tool. For Gantt chart, which is the key component in our project, we enable the multi-level timeline display, which means when you hover your cursor on the Gantt chart, you can zoom in or zoom out to see the details or the overview of events. Also, we color-coded the different events for clarity. For the generative LLM, we use the Gemini server, and it will output the patient background, encounter summary, and also the medical history. Also, for the error handling part, in case user submit an invalid bundle, we can show an error message asking users to try again. And also, in case there are some server issues when processing the summary, we also provide a button which user can click to try to generate the summary again. However, we still have some challenges. The first one is the compatibilities. Because our app runs totally in the browser, we ask users to use recent desktop browsers. Besides, we did not optimize for the mobile browser, so which means if you open the app using your mobile browser, this app may look a little bit squishy. There are also some small security concerns we have in our app. For example, we do not have checkouts for the LLM summary. And also, we hard-code our API key in our app, which basically means users can look at the source code and find the API key and use them whatever they want. We also do not have a rate limiter, and so which means it is likely to be abused if we do not add any controls over that. Functionally, we are hoping to add some more interactivities for our LLM summary. So instead of just summarizing the bundle, we hope to increase the interactivities by adding the chatbot-like functions, so users can ask questions and get fast response from the LLM summary.
Finally, I will be discussing future work and the conclusion. So first, we used a fully front-end app for our project, and while this was a quick and simple deployment, there are several concerns, including security, because our Gemini API key was exposed. browser compatibility issues, as well as weak performance of the app. And if the project were to proceed to a production environment, creating a backend server would really be key in this. This would improve security of the app, so kind of removing that exposure of our API key and doing that call server side, as well as better browser compatibility, enhanced performance, as we could do a lot of server-side processing and scale that as the app progresses, as well as better validation. So we could handle incomplete or missing data within FHIR bundles on the server more easily. So yeah. Another potential improvement of the project would be improving the AI summary portion. So this would mean kind of allowing clinicians to query the FHIR bundle using natural language queries. So just asking pointed questions about the patient and their history. This would allow more tailored summaries for specific resources. So clinicians could ask specifically about procedures, encounters, and that could really empower them to find the data that they need quickly. And so on the right is an example of what this could look like from Notebook LM from Google. So you can see the summary on the left with a chat allowing them to ask pointed questions about the resource. So something like this could really help clinicians. In conclusion, our FHIR bundle timeline visualization tool did successfully address the need for improved time-based data visualization in healthcare. And through our interactive timeline and AI summary, we enhanced clinical decision-making. We also reduced data retrieval time, and we also provide more clear of patients' histories to clinicians. Yep, thank you.